Welcome to this video on induction for divisibility. Here we are to use induction to prove that 5 divides cleanly into the numerical value of this expression for all n drawn from the natural numbers. Before we begin, I'll just point out that sometimes this question is written in a more compact form, required to prove that 5 divides cleanly into 8 to the n minus 3 to the n for all n drawn from the natural numbers. The upside down capital A is a math symbol, which means for all or for each. And this vertical line here is an observation, required to prove that 5 will divide cleanly into this expression. Okay, before we continue, let's introduce a nice compact notation. So I'm going to say let t, n, take on the value of 8 to the n minus 3 to the n, and I can use these two interchangeably in what comes. All right, let's have a look at what's next. Step number 1 in all induction problems is this. Required to prove conjecture true for n equals 1. Now it's a conjecture because we haven't proven it yet. Once we've proven it, you can call it a fact. Until then, it's merely a conjecture. So let's look at what happens to this expression when n is 1. We have 8 to the 1 minus 3 to the 1 is 5, and surely 5 divides 5, so check, it passes the first test. The conjecture is true when n is at least 1. The second stage is to assume the conjecture is true when n equals k. This is a strange step that often bothers students, but we'll explain it thoroughly. So that means we are assuming that 5 will divide cleanly into 8 to the k minus 3 to the k. That is, using our new notation, to assume that 5 divides cleanly into tk. Alrighty, on to the third step. We are required to prove the conjecture is true for n equals k plus 1. That is, we are required to prove that 5 divides cleanly into 8 to the k plus 1 minus 3 to the k plus 1. Or that 5 divides cleanly into tk plus 1. Okay, now the relationship between these two steps is that if the conjecture is true for the kth integer, it will guarantee the truth of the conjecture for the k plus first integer. We don't know that this is true. We're merely setting up a situation where if this is true, then this will also be true, right? The truth of the conjecture for the kth integer induces the truth of the conjecture for the k plus first integer. That's why it's called induction. Okay, now it's difficult to attack this problem directly, right? To actually prove this directly. So we start in a very clever way. What we do is we look at the incremental difference between the adjacent terms tk and tk plus 1. We look at what you would add to term tk to get tk plus 1. And we ask ourselves if we can prove that that is a multiple of 5. After all, if tk is a multiple of 5, then, and the incremental difference between tk and tk plus 1 is a multiple of 5, then tk plus 1 itself will be a multiple of 5. So we're going to consider this. Consider the difference between two adjacent terms, tk plus 1 and tk. Right? And if we do that, we've got this. 8 to the k plus 1 minus 3 to the k plus 1 minus 8 to the k minus 3 to the k. This is the quantity that you would add to the kth term to get the k plus first term. If this is a multiple of 5 and this is a multiple of 5, then this must be a multiple of 5, is our thinking. That's our approach. Let's simplify this expression and see what happens. So this becomes I'm going to actually write this term down here as 8 times 8 to the k. And then I'm going to write this term next as minus 8 to the k. Then I'm going to write this term next as 3 times 3 to the k. And then the double negative here means this term turns into plus 3 to the k. Doing well. Everything's fine here. Then I'm going to factor in pairs. I'm going to factor the 8 to the k from this term and the 3 to the k from this term. And that's going to give us 8 to the k times 8 minus 1. And here I've got plus 3 to the k times negative 3 plus 1. And that simplifies down to 7 times 8 to the k minus 2 times 3 to the k. Now here you have to use your imagination a little bit. This is the toughest point in the whole solution. You're looking for this to be a multiple of 5. What we can do is we can break the 7 up into 5 and 2. So this guy becomes 5 times 8 to the k, and this is something you use your own initiative to do. There's nothing pointing you in that direction other than your desire to get a multiple of 5 out of it. So this seems like a sensible way to break down this 7 times 8 to the k. 5 times 8 to the k plus 2 times 8 to the k minus 2 times 3 to the k. Now look what we've got here. This is a multiple of 5, which is good. We'll leave that. That's success. And here I'm going to factor the 2 out, see what we get. So I've got 5 times 8 to the k plus 2 times 8 to the k minus 3 to the k. We recognize that as term tk. So this is 5 times 8 to the k plus 2 tk. But wait, the left side, remember what the left side is. The left side is this, tk plus 1 minus tk, remember? What I'm going to do now is add tk to both sides, and that gives you tk plus 1 equals 5 times 8 to the k plus 3 copies of tk. Now we go back and run the induction thinking by this equation here. Remember, if 5 divides cleanly into tk, will 5 also divide cleanly into tk plus 1? Well, let's have a look. Let's think about this. Assuming 5 is divisible cleanly into tk, then if you triple that, it's still divisible by 5. And this is a multiple of 5. So we're taking something we know to be divisible by 5 and we're adding a multiple of 5 to it. If that is the way that's unfolding, then this must also be divisible by 5 because you're adding a multiple of 5 to it and something which is known to be a multiple of 5. So this is going to be divisible by 5. And that's the end of our proof. Now, remember, the first step, I promised I'd come back to the first step. What was the reasoning behind the first step? You had to show that the conjecture was true for the first integer. Because this is merely an abstract situation here. Steps 2 and 3 is an abstract situation. You're just saying, you're proving that if it's true for the kth integer, it's true for the k plus first integer. That's all you proved. You proved the link between those two. You have to prove that it's true somewhere, namely the first integer, for this to be valid. That's why that's a very important step, the first step there. So let's wrap it up. Let's go on to a new page and finish it up now. How would you write this up? At this stage here, you could say, therefore, 5 divides 8 to the n minus 3 to the n as required for all n in the natural numbers. And you're finished with that. That's done. Great. If you enjoyed this video, please like, subscribe, and share. In the comments section below, please post suggestions of any topics you'd like to see covered. Thank you very much.